When we look up, on a clear moonless night, away from any city lights, we can see thousands of stars glistening above us. But these are only a tiny portion of the stars that make up the Milky Way galaxy, our galactic home. Beyond what we can see in the night sky are hundreds of billions of other stars, and beyond the Milky Way are billions of other vast galaxies. That bright smudge of light ahead is our sister galaxy, Andromeda, the closest large galaxy to ours and the most distant thing most of us humans can see with the unaided eye. From Earth, it is around 2.5 million light-years away, an incredibly vast distance. But luckily, by using this simulation, we can travel faster than the speed of light. We can leave our solar system within a blink of an eye. The planet that every single human has ever existed upon is now just a tiny speck. The Sun, just another star in a sea of bright dots. To understand the sheer scale of the Milky Way galaxy, however, we need to travel more than 500 light-years vertically, a journey that will allow us to see our galactic home in all its glory. The Milky Way is a barred spiral galaxy and is around 13.6 billion years old. Large pivoting arms can be seen stretching out across the cosmos, creating a disk shape that spans an area more than 100,000 light-years. It's incredible to think that our star, the Sun, is just one of an uncountable number of stars that make up this galaxy. Although it has been estimated to contain between 100 billion and 400 billion stars. As we drift ever further from the Milky Way's bright glare, look into the distance, and you will see many mysterious glowing dots. These are entire galaxies scattered across the observable universe. You may notice that the galaxies are not scattered randomly. Instead, they are grouped in gravitationally bound clusters, interspersed with vast dark voids, giving the universe a magnificent cobweb-like structure. The observable universe contains at least 100 billion galaxies, but there are possibly trillions, and they come in all kinds of different shapes and sizes. Most of these galaxies are extremely far away, however, and can only be seen with powerful telescopes. But there are some that are, cosmically speaking, relatively close to the Milky Way, close enough to be part of what's called the local group. This group is a vast cluster of more than 30 galaxies, all within a space of around 10 million light-years or so. The Milky Way is just one of 3 large galaxies in the local group, but it's not the largest. That would be the one that we are currently heading towards, the Andromeda Galaxy. The magnificent cosmic structure is named after the area from which it can be seen in the Earth's sky, the Andromeda constellation, which itself is named after the Ethiopian princess who, according to Greek mythology, was saved from certain death by the hero, Perseus. Like the Milky Way, Andromeda is a barred spiral galaxy with enormous circling arms containing a wealth of gas, dust, and bright stars. Andromeda is significantly bigger than the Milky Way, however, spanning an area more than 200,000 light-years across. It also contains many more stars, estimated to be around the 1 trillion mark. At its center, within that bright bulge, hides a mysterious supermassive black hole that is estimated to have a diameter of 516 million miles, which is 830 million kilometers, larger than Jupiter's orbit. It contains enough mass to equal that of 140 million suns. Compared to Sagittarius A*, the supermassive black hole at the center of the Milky Way, which only contains the same amount of mass as 4 million suns, this supermassive black hole is truly colossal. However, it's not just individual stars that orbit the center of this enormous galaxy. That bright yellowish object just off to the side is called M110 and is one of many satellite galaxies that are gravitationally bound to Andromeda. These less massive galaxies have their own impressive collection of stars, all of which orbit their own center, but the galaxies and everything in them also orbit Andromeda. Like how the Moon orbits the Earth, yet the Earth and the Moon orbit the Sun. The Andromeda Galaxy is roughly 2.5 million light-years from the Milky Way, but that won't always be the case. Because both are on a collision course that will ultimately alter the structure of each galaxy forever. The galaxies are rushing closer to one another at about 70 miles per second, which is 112 kilometers per second, and it is estimated that the collision will begin in around 4.5 billion years from now. While this collision might seem like it could only end in destruction, galaxy mergers often lead to extreme bursts of star formation, leaving the night sky awash with bright, new stars. Although unfortunately, humans probably won't be around long enough to see this majestic cosmic show play out. Regardless of what we will miss in the future, one thing we can do right now is go outside on a clear night and look up into the sky. Find the constellation of Andromeda, then the galaxy, and marvel at the only thing that we can see with the unaided eye that isn't part of the Milky Way. But that will one day join our galactic home and create a new galaxy, the Andromeda Galaxy. Did you enjoy your journey to Andromeda? The Milky Way galaxy is our home in the universe. It's a vast, barred spiral galaxy that spans over 100,000 light-years in diameter and contains an estimated 100 to 400 billion stars. At the center of our galaxy lies a supermassive black hole, Sagittarius A*, which is about 4 million times the mass of our Sun. This black hole is responsible for the gravitational pull that holds the entire galaxy together. The Milky Way itself is made up of several components: the nuclear bulge, the disk, and the halo. The nuclear bulge is where the supermassive black hole is located, and it's densely packed with older stars and gas. The disk contains the majority of stars, including our Sun, as well as gas and dust. This disk is where we find the well-known spiral arms, which are regions of active star formation. The halo contains globular clusters and a sparse collection of stars and dark matter. The Milky Way spiral arms are spread out in a spiral shape that resembles a pinwheel. These arms are rich in gas, dust, and new stars, which is why they shine brightly. Our solar system resides in one of the smaller arms, called the Orion Arm, also known as the local spur. The Milky Way is about 13.6 billion years old, and it has been evolving ever since its formation. Andromeda, or M31, is the closest spiral galaxy to the Milky Way and is about 2.5 million light-years away. It's a massive galaxy, with a diameter of over 220,000 light-years, more than double the size of the Milky Way. Andromeda is home to about 1 trillion stars, compared to the Milky Way's 100 to 400 billion stars. At the center of Andromeda, there lies a supermassive black hole much larger than Sagittarius A* in the Milky Way. This black hole, with a mass 140 million times that of the Sun, has a diameter of 516 million miles, about 830 million kilometers, which is larger than the orbit of Jupiter in our solar system. Andromeda also has several satellite galaxies, including M32, M110, and others, which are smaller galaxies that orbit Andromeda. These satellite galaxies are gravitationally bound to Andromeda and move around it, much like how our Moon orbits Earth. These galaxies contain their own collections of stars, but they are part of the Andromeda Galaxy's larger structure. Andromeda and the Milky Way are part of a galaxy cluster known as the Local Group. This group contains more than 30 galaxies, and the Milky Way and Andromeda are the two largest members. Other members of the Local Group include the Triangulum Galaxy, M33, which is another spiral galaxy, as well as many smaller, irregular galaxies. The Local Group spans about 10 million light-years across, and the galaxies within it are gravitationally bound, meaning they are all moving in relation to each other. This local neighborhood of galaxies is just a small part of the Virgo supercluster, which contains thousands of galaxies spread out across an even larger region of space. One of the most fascinating aspects of the relationship between the Milky Way and Andromeda is that these two galaxies are on a collision course. The galaxies are moving toward each other at a speed of 70 miles per second, 112 kilometers per second, and it is estimated that they will collide in about 4.5 billion years. While this might sound like a catastrophic event, galaxy collisions are common in the universe and can lead to the formation of new stars. The collision between the Milky Way and Andromeda will likely result in a new galaxy that is a mix of both galaxies, sometimes referred to as Milkomeda. The collision will cause massive stellar explosions and the creation of new star systems. However, due to the vast distances between stars, it's unlikely that individual stars will collide with one another. Instead, the gas and dust in both galaxies will interact, leading to bursts of star formation. Interestingly, the two galaxies will likely pass through each other several times before they merge completely. After the merger, the resulting galaxy will likely no longer be a spiral galaxy but rather an elliptical galaxy, which is a type of galaxy that has a more spherical shape and consists mostly of older stars. Beyond our immediate galactic neighborhood, the observable universe is filled with billions of galaxies, each containing its own collection of stars, gas, and planets. These galaxies are not distributed randomly throughout space but rather are found in gravitationally bound clusters, with vast voids in between them. This distribution gives the universe a web-like structure, often referred to as the cosmic web. The observable universe is thought to contain at least 100 billion galaxies, but there could be trillions of galaxies in total, especially considering regions beyond what we can currently observe. Many of these galaxies are so distant that their light takes billions of years to reach us, and we can only detect them using powerful telescopes such as the Hubble Space Telescope or the James Webb Space Telescope. The distances between objects in space are vast and difficult to comprehend. A light year is the distance that light travels in 1 year, approximately 5.88 trillion miles, or 9.46 trillion kilometers. When we say that Andromeda is 2.5 million light-years away, it means that the light we see from that galaxy today actually left it 2.5 million years ago. This means that when we look at distant galaxies, we are effectively looking back in time, seeing them as they were in the past. The scale of the universe is truly mind-boggling, and these distances are just a tiny fraction of the entire universe. Beyond the local group, galaxies are moving away from us due to the expansion of the universe, as described by Hubble's law, which states that galaxies are receding from each other at speeds proportional to their distances. Despite the immense distances between stars and galaxies, we can still experience the grandeur of the universe by looking up at the night sky. On a clear, moonless night, away from the city lights, we can see thousands of stars with the naked eye. In some cases, we can even see galaxies like Andromeda, the only galaxy visible to the naked eye from Earth outside the Milky Way. By observing the night sky, we are connecting with the deep history and vastness of the cosmos, reminding ourselves of how small our planet is in the grand scheme of the universe. The universe is an ever-evolving and awe-inspiring place. As our technology improves, we continue to make new discoveries that help us understand more about the stars, galaxies, and the incredible forces that govern our existence. While we may never see the merger of the Milky Way and Andromeda, we can still appreciate the beauty and mystery of the cosmos that surrounds us.